Okay, this is the video solutions for solving radical equations. And let me write down again the idea behind this that we discussed in lecture. If I have a left side equal a right side, okay, then what I can do is the following. I can actually square both sides. Or I can raise both sides to the third power or the fourth power. So I can square both sides or raise both sides to the third power, like I said. Or I can raise both sides to the general nth power. And typically this is used here to get rid of a radical. And this is kind of why we have this fact and why we use it is we want to get rid of a radical. And in the case of a square root, what you have here is that raising both sides actually gets rid of the radical. So if we take a closer look, the square root of x is a positive 2. I can square both sides here. And on the left side, there's different ways we could go about this. We can say, square root of x times the square root of x is 4, because that's what 2 squared is. This is the square root of x squared, I guess, right? By the product rule is 4. And this means that x is actually what? 4. Okay? So this is one way we could go about this. The second way we can think of this, so people are aware, is we can actually write your radical. If we have, let's go back in black and say, okay, we have the square root of x is 2. We can write this radical as x to the 1/2 power. Okay? Because again, our index here is 2. And so we write it as a base. It's an exponential that has a rational power, a fraction power, where the index is down here as a denominator in the fraction. So when you now go and square both sides, we use properties of exponents and say this is 1/2 times my 2 is 4. And then 1/2 times 2 is 1. In other words, again, you can see that x is the value 4. So this is what was discussed in class. This is the idea and the approach behind squaring both sides to get rid of a square root. And I gave it to you in terms of a fact here, that if you have a left side equals a right side, and this is used really to get rid of a radical, then just square both sides. And in this case, the radical is a square root. Square both sides. If it was a cube root, you would cube both sides, and we'll see some of those. A fourth root, we discussed those in class. So this is what we're going to use for our homework today. Okay? And that was number 1. So x is the value 4. Now, let's kind of notice something here. Let's see what's going on. We have the square root of x is actually 2. Remember, what does it mean to be a solution? Go back and plug in the value for x being 4. And we get the square root of 4 is actually 2, or 2 is a square root of 2. Now, this here is a true statement. And so we know that x is the value 4 is a solution to this radical equation, or square root equation. And it's one solution here. So in back of the book, you might see just simply the square root of 4 as an answer. Okay? At least in solution set notation. So that's what we're going to be doing today. Number 3. The square root of x is 4. Square both sides. X is 4 squared, or we say x is 16. There's a single value as a solution. And let's note, here we do it this way. The square root of 16 is in fact 4. That's a true statement. Number 5. The square root of x is negative 5. We're going to square both sides here. Notice we get x on the left, and that's going to equal negative 5 times negative 5, or we say x is 25. Let's note, the square root of x is supposed to be negative 5. And in this case here, x gets replaced with 25. So the square root of 25, if we take a look here, is actually positive 5. This here is a false statement. Now, in an intermediate algebra, Math 125, intermediate algebra setting, what we say in this case is there's no real solution to this equation. And if you're looking back at the book, you'll see this empty set sign symbol representing the fact that there is no real solution, no real value solution. So what we're going to say here is the same thing. There's no solution, no real value solution. We could put the empty set, and that always happens. Always happens. If you have, here's my remark. The square root of x is a negative, meaning it's a negative value, okay? If you have the square root of x being a negative value, there's no real solution, okay? The solution set is empty. If you remember, a picture of the empty set is a set that's empty. That always happens when you have the square root being a negative. Number 7. The square root of x minus 3 is 0. We can apply the squaring of both sides at this point. So we're going to add 3 to both sides, and what you end up getting here is square root of x equals 3. So maybe at this point, let's note, if I had to give you guys a fact to use for homework, and what we want to remember is that if I have the square root of x equals let's say, I don't want to use an, let's say it's p, where this p value is both positive or 0. It really means that the p-value is non-negative. It's a non-negative number. So maybe it's better for us to use a different letter. How about if we just use the letter M? And so the idea, at least fundamentally today, is if the square root of x is m, then by squaring both sides, just so you guys know, as a formula, x will be m squared. Because remember, you're just going to simply square both sides to get rid of the radical. And on the left side, you have simply x. On the right side, it's m squared. So that's what we're doing here, really, today with this homework assignment. And maybe this is actually the real fact you want to use. And remember, it's a formula, and it's the opposite in some ways of the square root formula. You know, this now is, if we have the square root of x as a non-negative number, then we can say x is m squared. So this is kind of today the real essence of the lesson. And now we're going to apply it. Since we have, the square root of x equals m, then that means x will be 3 squared, or that x will be the value 9. Notice that the square root of 9 is supposed to be 3, and it's actually a true statement. So 9 is our solution. Question 9. The square root of x minus 1 is 0. We don't have it in this square root of x equals m format yet, but we will by adding 1 to both sides. And we get the square root of x is positive 1. This means x will be 1. Let's put this in red. 1 squared. And we know what 1 squared is. X is 1. If we want to write it in solution set format, there we go. Number 11. The square root of x plus 7 is 0. We're going to have to subtract 7 from both sides. We get the square root of x is negative 7. This is a negative number. So because there's a negative number, we say no real solution. The solution set is empty. (13) 2 times the square root of x minus 10 is 0. Now, what we're going to do here is, let's put this in red, solve for the square root of x so that you can use the fact I gave you way back in number 7. So you could use the formula. And you're going to get that by adding 10 here to both sides. And we now get 2 square root of x is 10. Divide both sides by your 2. Square root of x is 10 divided by 2, which is 5. Now, you can square both sides, or you could use the fact. Let's notice. This number is positive. It's non-negative. It's not negative. So I can use my fact, and I can say x will be 5 to the second power. And that means x is 25. This is our solution as a solution set. Number 15. 3 times the square root of x minus 18 is 0. Once again, solve for your radical. Add 18 to both sides. 3 square root of x is 18. Divide both sides by 3. We're solving for the radical. Get the square root of x is actually 9. This number is non-negative. It's not negative. Specifically, it's positive. We can use the formula. X will be 9 squared, or x is 81. Here's our solution. We're going to have to solve for the radical here. Okay? And I'm going to point out another idea here. Let's note a couple of things. Well, first, solve for the radical. We're going to add 16 both sides. Get 4 times the square root of x minus 1 is positive 16. Divide both sides by 4. So the x minus 1 is 16 divided by 4, which is 4. Now, here's something that I want to point out to you, to be specific. If you have the square root of anything equals m, and once again, this has to be a non-negative number. if we have that, this is the generalization of the statement I gave you earlier, then I can say that what you have there is actually m squared. Okay? This is the generalization. So what that means for us in this setting here is that since I have already the square root of something under my radical, an x minus 1 in this case, is a non-negative number, I can say that that x minus 1 is actually 4 to the second power. And x minus 1 being 4 to the second power says to me that I have a 16. We're now going to add 1 to both sides, and then we get x equal to 17. 17 is the solution set. And we're done. That's number 17. Number 19 is 4 times the square root of x minus 3 minus 20 is 0. We're going to add 20 to both sides. We end up with 4 square root x minus 3 is 20. You divide both sides by 4. Square root x minus 3 is 5. This 5 here is a non-negative number, so that means x minus 3 will be 5 squared. Or we say x minus 3 will be 25. Let's add 3 to both sides, and I get x equal to 28. 28 is the solution set, and that's number 19. 21, 4 square root x minus 2 minus 24 is 0. Solve for the radical. Get 4 square root x minus 2 is positive 24. Now, we're going to divide both sides here by 4 so we can solve for the radical. And we get square root of x minus 2 is 6. Now, the 6 again is a non-negative, which is good. We'll get x minus 2 is 6 squared now. Or x minus 2 is 36. We can add 2 to both sides. X will be 38. Our solution is 38. 23. Negative 5 square root x plus 1 minus 25 is 0. Again, we solve for the radical. Start by adding 25 to both sides. Negative 5 square root x plus 1 is 25. You're going to divide both sides by negative 5 here. Let's see what happens to the radical. You'll get square root of x plus 1 is a negative 5. Here we go. This is a problem. The radical could never be negative. Square roots here could never be negative. There is no real solution. Solution set is empty. Number 25. Negative 2 square root x plus 1 plus 20 is 0. Solve for the radical. Subtract the 20 from both sides. Negative 2 square root of x plus 1 is negative 20. Divide both sides by negative 20, or negative 2 here. Square root of x plus 1 is positive 10. X plus 1 becomes 10 squared. X plus 1 is 100. Subtract your 1 from both sides. X is 99. The solution set is 99. Square root of 2x is 3. Now again, 3 is a nice non-negative number, simply not negative. That means 2x will be 3 squared, or 2x will be 9. Divide both sides by 2. X is 9 halves. Here's your solution set. So x plus 1 is 5. Again, a non-negative answer. 2x plus 1 is 5 squared. 2x plus 1 is 25. Subtract 1. You get 2x will be 24. Divide both sides by 2. Excuse me. X is 12. This is our solution set. Square root 3x minus 4 is 3. Notice a nice non-negative number. So 3x minus 4 will become 3 squared, or 3x minus 4 is 9. Add 4 to both sides. 3x will equal 13. Divide both sides by 3. X is 13 thirds. And you're done. The square root of 2x minus 3 is the square root of x plus 4. Excuse me. Okay. You're going to square both sides. We get 2x minus 3 is x plus 4. By squaring both sides here, since we only have a single radical on the left and a single radical on the right, squaring both sides simply gets rid of both radicals. They're both gone. So now this becomes a nice simple equation, a linear equation to solve. We got x on opposite sides. This now gives us x minus 3 equal to 4. We can add 3 to both sides. X is 7. Here's our solution. (35) 4x minus 3 square root of 2x plus 5. Going to square both sides. We get 4x minus 3 becomes 2x plus 5. Again, a nice linear equation. Subtract 2x from both sides here. We get 2x minus 3 is 5. And add 3. Get 2x is 8. Divide both sides by 2. We get x as the value 4. Four is our solution set. That leaves us to 37. You got the square root of x is x. Now, let me point out an interesting detail about this problem, or remind you guys something about this problem and the ones that are going to follow here, the next 37 to 48 problems. We're going to kick this up a bit because of the fact that here, it's not like you can say here x is negative or positive necessarily. It's a variable. It's not a nice number like a 4 or a 3 or even a 2. But we're going to go with the same idea with what we've been doing. We're going to square really again both sides. Okay? Let's go back to that. That means x is x squared. So you have to ask yourself at this point, what kind of an equation is this? And have you ever solved these kind of equations? And the answer is yes, because this is a nice quadratic, right? Your variable x has the highest power of 2, so it's a quadratic. So however you know how to solve quadratics, you guys remember you have to have 0 on one side. I can say this is x squared is x now. Subtract your x from both sides. Remember, to solve a quadratic, you have to have it set equal to 0. So now it's x squared minus x is 0. So here's what's going on with some of these kind of questions. You got some choices here to solve your nice quadratic. Let's remember, you can solve by factoring and using the 0 product rule. Yeah. Let's not even write it down. Solve by factoring and using the 0 product rule. Or you can solve really by the quadratic formula. So I have two choices. I can factor or use the quadratic formula. Whichever you like. Now personally, I like to factor. I'm going to factor out the greatest common factor here, which is x. Now my quotient becomes x minus 1. This is by factoring. The 0 product rule says that means x is 0 or x minus 1 is 0. If I add 1 to both sides, I get x is 1 or x is 0. These are my solutions that I get, 0 or 1, using a beginning algebra approach, which is by factoring and using the 0 product rule. Okay, so we can do this. My writing's getting a little sloppy because I'm tired and because this pen is a little slippery. It's difficult. So these are our choices. Now remember, x squared minus x is 0. If you go back to the quadratic formula worksheet, this is a, this is b, but c is 0. There is no c term. So by the quadratic formula, we say x is negative b plus or minus square root b squared minus 4ac, everything over 2a. So if a is 1 here, b we know is negative 1, and c is 0. So we get x being minus a minus 1 plus or minus negative 1 squared minus 4 times 1 times 0, everything over 2 times 1. If we notice what's going on with this radical, negative 1 squared is 1. The portion out here is simply 0. So I could say negative 1 minus 0, or the square root of negative 1, which is 1. This radical gets replaced with 1. Don't forget, minus the minus makes this a plus. My radical is 1. And then 2 times 1 is the value 2. So we did this in our homework for the quadratic formula. So let's see here. X will be 1 plus or minus 1 over 2. So that means x is 1 plus 1 over 2. Or x is 1 minus 1 over 2. 2 over 2, which is 1. 0 over 2, which is 0. So as you guys can see, you get 0, 1 as a solution set again. 0, 1. And it's funny, my zeros look weird. Almost like the empty set. Okay. You get 0, 1 as a solution set. You did this by the quadratic formula, or we did it by factoring and using the zero product rule. So my favorite approach here is to factor and use the zero product rule, meaning x squared minus x becomes x times x minus 1, and that actually gives us a zero product rule. I have to solve two equations, and you get this final answer. So notice this is a little bit shorter by factoring. However, if you forgot factoring, I guess you got to use that quadratic formula or review factoring. And as you can see, using the quadratic formula does take some time and work. It can be done. It just is actually, all this kind of work here you're going to have to do. So there is some benefit to factoring. I love to factor. And that's what's going to happen in this next set of questions that you have on your homework, is you're going to have, probably factoring to do. And that's actually a good thing. So hopefully you can remember this. Now, 39, if you take a look, remember factoring, is we got the variables. This isn't the square root equals a non-negative number anymore. So what you can do, again, is square both sides. Okay? Square both sides. And what you end up with will be really 3 squared times the square root of x squared equals x squared, or you get 9x is x squared. So however you want to look at this, middle portion right here, you can say 3 square root of x times 3 square root of x is x squared, and that gives you 9x is x squared. Now, x squared minus 9, let's just give you every detail. X squared then becomes actually 9x. Subtract your 9x from both sides. You now get x squared minus 9x becomes a nice 0. Now again, I love to factor, and that's what I'm going to do. Maybe we should change your color here. X times x minus 9 when you factored. Zero product rule. X is 0. X minus 9 is 0. Add your 9 to both sides. We know x is 0 and x is 9. Now we can say this is the solution set 0, 9, but there's a little bit more going on here. I didn't talk about it in 37. But what I want to do now is check to see whether these are actually solutions. Now I already know my solution set is 0, 1, so let me go back and erase all this here so you guys can see what I'm talking about. Here's what you should do. I'm going to do that for 37 and 39. If you remember on our homework. Okay? Let's check. What does it mean to be a solution? It means if I plug back these values, I get a true statement. So let's plug back. X is 0. Let's change the color. Does this give me a true statement? Right? Square root of 0 is 0, or 0, 0. That's a true statement. That means x is 0, this value here, is a solution. So we're good. But now plug in x as 1. So the square root of 1 is 1, or 1 equals 1, and that's also a true statement. So we're good. this is the actual solution set. You're looking back at the book, you'll see 0, 1, as solutions. So, we're going to do this for our questions. We're going to check to see whether they're really solutions. In the case of 39, though, we go back and we found that x is 0 and x is 9. So if I look at the original equation, which is 3 square root of x is x, I'm going to now go plug in a 0 and a 9. But 3 times the square root of 0 is 0. 3 times 0 is 0. Or simply 0 is 0. Let's plug in a 9 now. 3 square root of 9 is 9. 3 times 3 is 9. Or 9 is 9. In both cases, we get true statements. That means the solution set is, in fact, what we see it here to be, which is going to be 0, 9, and that's for number 39. So we checked our solution and their actual solutions. That brings us up to question number 41. And for 41, we get the square root of x minus 1 is x minus 3. This is a little bit different and interesting. We square, again, both sides. These are some of the questions we did in class. So you're going to square both sides here. Now what happens now is on the left side, we get x minus 1. On the right side is x minus 3 times x minus 3. You're going to have to use FOIL. X minus 1 becomes x squared minus 3x plus 9 by FOIL, or x squared minus 6x plus 9. You get an x minus 1. Subtract your x. Negative 1 is x squared minus 7x plus 9. You're going to add 1, and you end up with 0 is x squared minus 7x plus your 10. Or we say x squared, what was that? That was minus 7x. Minus 7x plus 10 is 0. We're going to solve this by factoring. This is minus 2 and minus 5. By the zero product rule, x minus 2 is 0, and x minus 5 is 0. Add 2, add 5. X is 2, and x is 5. So we can start to say, I think the solution set is going to be, 2, 5. But we have to check. Got to go back to the original equation. The original equation is the square root of x minus 1 is x minus 3. Okay? Now remember, this original equation, it does have a radical, but I want to point out to you that this side over here is what's in question. Remember, that side cannot be, again, negative. So we're going to check. If I plug in the 5, notice 5 minus 3 is positive 2. Okay? We're going to have a radical then of x minus 1 is positive 2. If I plug in the 5 here, we do get 5 minus 1, which is 4. It's hard to see. Let me just point this out to you. Plugging in x is 5 gives me the square root of 5 minus 1 is 5 minus 3. The square root of 4 is 2. That's a true statement, and that should be something we actually realize because of the fact that 5 minus 3 is a positive 2 on the right side. So it's non-negative. Now, consider that idea. on the right side, it has to be non-negative. What if I plug in 2? 2 minus 3 is negative 1. We can't have a radical equal to a negative. So if I plug in 2 for both of these now, notice we get the square root of 2 minus 1 is 2 minus 3. The square root of negative 1 is negative 1. I is not negative 1. Okay? In other words, plugging in the value of 2 makes my right side equal to a negative. And as you guys can see, that means the following, that 2 is not really a solution here. Okay? 2 is known as extraneous. We have extraneous solutions. Throw that out. Throw out the 2 as a solution. It's extra and not necessary and not even valid, at least in the real number sense. And guess what, ladies and gentlemen? You have a single solution, which is going to be the 5. So yeah, get rid of this 2. As a solution, you have a single solution. Okay? So it's kind of simple to find if that radical equals a negative, then you have a problem. The radical has to be a positive. And so this is the work you'll do, and that one's number 41. That leaves us now to 43. So 43 here. X equals the square root of x plus 7 plus your 5. Again, subtract 5 from both sides. You end up with x minus 5 equals the square root of x plus 7. Now, this is written a little differently. You have the x minus 5 without a radical on the left, and you have the radical on the right side. It's no big deal. Square both sides again. We get x minus 5 to the second power here, is x plus 7. My radical went away on the right side. Now, on the left, we use FOIL. That's x minus 5 times x minus 5 here is x plus 7. X squared minus 5x plus 25 is x plus 7. X squared minus 10x plus 25 is x plus 7. Subtract x. X squared minus 11x plus 25 is 7. Subtract your 7. X squared minus 11x plus 18 is 0. X and x. 9 and 2. Minus 9 minus 2. X minus 9 is 0. X minus 2 is 0. Here's what you're going to do. Add 9. Add 2. X is 9. X is 2. So, these are my solutions. Or are they? Go back. Go back over here. Notice that if I plug in a 9, nine minus 5 is 4, and that's positive. So we're good there. Let's say I plug in a 2. 2 minus 5 is a negative 3. So what that's going to mean here, and you guys can verify this by actually going through the process, that's going to mean that my 2 here, okay, is extraneous. get rid of it as part of the solution set. There's only one answer, and it's positive 9. So double check there in your radical, verify that you get a true statement, but that's what you're going to find. It's only one solution there. Number 45. Square root of x plus 9 is going to be square root of x minus 6 plus 3. Now, if you have to go to the bathroom, this might be a good time to do so. Or if you want to get a drink of water, this might be a good time to do so. You're going to see why. So let's start off the process like we have today on this lecture, like we did in class. Sorry. We're going to square both sides. Still no good. Now on the left side, the radical goes away. The thing about this is, what's going on this right side? Since the right side here, ladies and gentlemen, is a sum. Okay, now let me put that right in the middle so it looks a little better. Since the right side here is a sum here of two terms, whenever you square a sum or a difference, you know what that means. You're going to have to use FOIL. So I have the square root of x minus 6 plus 3 times the square root of x minus 6 plus my 3. This is starting to get a little bit difficult to write, so bear with me. Let's be careful. X minus 6 plus 3, square root of x minus 6 plus 3. You're going to have to use FOIL. So you're going to bring out the FOIL box. And here's what I recommend when you bring out the FOIL box. Just take your time. Do it right. Square root of x minus 6 over 3. Square root of x minus 6 and 3. Square root of x minus 6 times square root of x minus 6 is x minus 6. The radical times a number, you get 3 square root of x minus 6. 3 square root of x minus 6, and 3 times 3 is 9. And so on the right side here, when we use FOIL, I'm going to have to combine all of these terms here and see what I get. That's just on the right side. So, okay, don't forget on the left, I have x plus 9, but on the right, let's see what we have here. We got x minus 6. And then notice that I have 3 times a radical and another 3 times a radical. And that's going to give me plus 6 times the radical of that x minus 6. And then I have plus 9. X plus 9 becomes x plus 6 times the square root of x minus 6. And this is going to be plus my 3 now, because I combined my negative 6 here with my positive 9, and that gives me plus 3. So I combined my like terms on the right side. So as you guys can see, yes, it starts to become involved at this point. You solve for your radical. Now, solving for the radical here, you subtract x from both sides. You subtract 3 from both sides. And we get 6 equals 6 square root x minus 6. And yeah, let's double check the work. It looks like we're good. Okay, now divide both sides by the 6. And I end up with 1 let's write it this way, is the square root of x minus 6. We got cancellation. And you get the square root of x minus 6 is 1. Square both sides. X minus 6 becomes 1 squared. X minus 6 is 1. Add 6. You get x is 7. So, x is 7. The real question is this really a solution for x is 7 here? I get the following. This is actually number 45. So we have the square root of x plus 9 is supposed to equal the square root of x minus 6 plus my 3. Plug in your 7 here for x. We end up getting the square root of 7 plus 9, and that's 16. The square root of 7 minus 6, which is 1, and that's supposed to be plus 3. 4 is 1 plus 3. This is a true statement. This is 45. 47, square root of 2x plus 3 minus the square root of x minus 1 is 1. Now this is just like number 47, but what we're going to do here is solve for a radical. We can simply add the square root of x minus 1 to both sides here. And you're going to get now the square root of 2x plus 3 equal to the square root of x minus 1 plus 1. And again, we solve for this radical because in order to get rid of your radicals, you're going to have to square both sides. And as you guys can see on the right side again, we got FOIL. So again, this might be another time to go make a sandwich or go, go to the grocery store, whatever. This is going to take some time. So just be patient. Use FOIL. And on the left, you get 2x plus 3. Well, I guess if we're going to use FOIL, we have to bring out our FOIL box. So now is a good time to bring out that FOIL box. Okay, I'm going to have the radical, x minus 1 and the number 1, x minus 1 and the number 1. First term is just x minus 1. The radical times 1 is the radical. So my own I terms are the same. It's not so bad. X minus 1 plus square root of x minus 1 plus square root of x minus 1 plus 1. My 1's cancel. And I get x plus, let's double check. Get x plus 2 square root of x minus 1. And that's on my right hand side. So altogether, don't forget on the left side, you have the 2x plus 3. So let's see what happens. 2x plus 3 here. 2x plus 3 on the left. And that equals, this. X plus 2 times my radical. And yet again, we're going to have to solve for this radical. Subtract x from both sides. You get x plus 3 is 2 square root of x minus 1. Now here's what I'm going to recommend. we're going to have to apply the idea, again, of squaring both sides so that we can get rid of our radical. And as you can see on the left, you got the x minus 3 squared. On the right, I have an exponential. So on my left, x plus 3 times x plus 3. On the right, this is 2 times x minus 1. Excuse me. It's actually 4. The reason being is because, let's emphasize this, 2 times 2 is where I got my 4. The square root of x minus 1 times the square root of x minus 1 is simply x minus 1 without the radical. And as you guys can see, we're going to have to use FOIL again. So x squared plus 3x plus 3x plus 9 is 4x minus 4 when I actually apply my distributive property here. That's minus 4. We're going to distribute. So here's the story. We get x squared plus 6x plus 9 is 4x minus 4. We have a nice quadratic. Well, sort of. We're going to have to set this equal to 0 on one side and solve for x. So we've been doing that, and we can do that by subtracting 4x from both sides here, and by adding 4 to both sides. So we end up with, let's see, x squared plus 2x plus 13 is 0. Let's double check. Four x minus 4, okay, x squared plus 6x plus 9 is 4x minus 4. Subtract my 4x, we get 2x. Add my 4, 9 and 4 is 13. Okay, let's double check here. 2x plus 3 minus x minus 1 is 1. Okay, let's check our work here. Okay. Looks like we're okay. Ah, I see a problem. This is supposed to be x minus 1. There it is. Let's double check. Yes. Is that it? Ah, there we go. Well, no, we're okay. We did it correct. X minus 1 plus 1. All right, this is x. We had an x plus 2 times the radical there. Okay, subtract the x. We get an x plus 3 is 2. Square that. It looks like we're good. Looks like we went all the way through. Okay. Now, notice this. I mean, I can't find the error. Some of you guys might. There may not be an error, but we can't factor. This is not factorable. No big deal. We bring out the big guns, and that's the quadratic formula. So x is negative b plus or minus square root b squared minus 4ac, everything over 2a. Identify your coefficients. 1, a is 1, b is 2, c is 13. So I put a 2, I put a 2, a 1, a 13, and a 1. X is negative 2 plus or minus 2 squared minus 4 times 1 times 13. Everything over 2 times 1. Negative 2 plus or minus 4 minus, looks like it's going to be 52 over 2. X is negative 2 plus or minus the square root of negative 48. Everything over 2. Okay. The radical. Let's go to negative 48. we're going to have to simplify this. It's going to be, first of all, square root of 48i. And this is 16 times 3i, which would be 4 square root of 3i. That's my radical. Negative 2 plus or minus 4 square root of 3i, everything over 2. Negative 2 over 2 plus or minus 4 square root of 3i over 2. Negative 1 plus or minus 2 square root of 3i. This is my solution. I'm going to write this as a solution set here, and we get negative 1 plus 2 square root of 3i, negative 1 minus 2 square root of 3i. And ladies and gentlemen, this is kind of going out of the scope of the course from an intermediate algebra course, and you just stepped into a more pre-calculus, calculus level version of all these problems. So nevertheless, we know how to do it since we know about complex solutions. And this concludes our homework set here for solving radical equations.